Hello, my name is Kaiwa Njashubim Magezi, and this is a program that creates a linked list, and I'm just going to explain what the program does and how it works. These are the function prototypes here, and this is our node created, a structure node created there, and there's a main function. We'll get to this in a few, and so let's first work on the function prototypes, implementing them. So for creating the node, first we allocate memory to the new node that we are creating. Then you check if the node is empty. If since new node is a pointer to the node, if if it doesn't have anything in it, that means it doesn't have an address, and therefore it's null, and that means that the memory has not been allocated, so it must first receive an address in it for it to not be null. And when it's not null, then we carry out the rest of the code. Then we can access the number bit of the structure, and the next, which will be null since there's now only one element. And yeah, we have created our new node. And printing we can take in the the head pointer to the node. The head pointer is pointing to the first item in the node. So we are assigning the address of the head pointer to another pointer called current, and we are going to first print the square bracket. Then every time current is not null, we are going to iterate a loop, a while loop, and we shall be printing the number in that structure. And every time the current is still not null, after moving to the link, accessing the next structure in the list, every time the current is still not null, we shall print a comma, and the process just repeats since it's a while loop until it actually evaluates to null. And then appending, for appending, we shall take in a pointer to a pointer, which is a head pointer, and an integer. And so what we are doing here is basically, first we create a node, we create a structure, and after creating, then we check if this pointer to the pointer is empty. If it doesn't have an address in it, then we assign it the new node as its new address. And so then we can continue to struct node. Then here we now assign another pointer current to the address in the head pointer. So while then we start a loop, iterating through using the current pointer, and every time we access the next the address in the next bit of the structure, then we assess the next item after, because it's like a link to the next, it's an address to the next element in the structure. So when we access that other element, we have to keep on checking if that element is null, and if it's not null, then we keep on like iterating through that that linked list. And so yeah, to add to it, then to append means to add at the end. So after it evaluating to null, then we assign that link, that address that is evaluating to null, we put the new node inside there, and therefore the link the list expands, because now the null bit is going to be in the in the new node structure now. So the part that is supposed to access another element, we shall have null there, and that's what this line of code here at where my pointer is on the screen, that's what that line of code does. Pardon me about that. Then prepending just means adding to the front. So what we are going to do here is first create a node. First create a node. After we create the nodes by calling the create node function, which we already declared first. It was the first function we declared. Then we access the link to the next element of the list, and we assign the head pointer to that link. And what this means is that since we have created a new node and we're going to add it to a list, we are getting since the head pointer points to the first element in the list, we are getting that address that is pointing to the first element in the list and putting it in the in the position that in the position of okay, we have a new structure, and in that position that accesses the next item of the list, we are putting the address that was formerly to the first formerly the address of the first element, and this makes that element now the second element. And after we do that, now the new node becomes our first element, and that's why we are saying that head pointer is now equal to new node, because now the head, since it points to the first element, it's going to point to the new node address. Now deleting by key, to delete by key, we are going to still taking the a pointer to the head and an integer and an integer, which is the key basically. So deleting by key just means deleting by reference, in other words the position in the list. And here we are going to be using actual references, which means the first element will be 0, like that. So first we are going to get 2 pointers. We need 2 pointers in this case. One that is going to be coming from behind, one is going to keep the previous address, and then is going to keep the address that is right in front of it. We're going to discuss why that is important. And if I'm going to first say that if the key is 0, in other words, if the element we want to delete is the first element, then in that case just assign the head pointer to the link. Now that element has a link to the, which is an address to the next element, right? So we are just going to get that address and now put it in the head, so that the head no longer accesses this the item in position 0 as the first, but it's now going to access the second, and that will make it now the first item of our list. And now else we're going to now create a while loop. So if the key now is not 0, what are we going to do? So we're going to get the pointer which we declared up here as current one, and assign it to the current pointer. Now remember, the current pointer for it it's pointing at the head, right? So if it's pointing at the head, in other words, that's the first element, then current one is going to now take on also point at the first element, because it's assigned, the address is assigned as current as well. So now what we are going to do is now move the current pointer now forward, so that the current one stores the address of the of the element before, and then the current pointer will now for it store the address of the element in front. In other words, if this one is storing the first element, current pointer will now, current one is storing the first, current pointer will now store the second. And so we do that by saying that current one is now going to store the initial position of current, which is the first element, and then current is now going to access the link to the next element, and that will now be assigned as its value as the address, which means it's now going to refer to the second element. And now with this we keep on reducing the value, because remember we brought in a key. So let's say the key is 3, so every time we iterate, the key reduces itself until it reaches 0, because when it reaches 0, now it will become false and will break out of the loop. And by the time it becomes false, then we have accessed the element that we are looking for, that we want to delete, right, by key. And that means that now we are going to get its reference, its link to the next element after it, and now we are going to get that link and put it in the element before it. And what that means basically means that that element is now going to be removed. The key position that we want to remove, it's going to go away. Why? Because it's no longer referenced in the since the element before for an item to be a structure to be accessed, it has to have its address in the item before it, in the structure before it. And if now that address has been changed to the address of the item after now that key position that we want, then we can't access this element anymore, and basically it has been deleted. And so we implement that by saying that current one is going to access its next element. In other words, we are now at the position where we have met the key, and remember, current one is lagging behind the current pointer, and so we are going to get we're going to access the link position of current one, the next position, the next address, and after accessing that, what we are going to do is initialize it now to the address that was now in the structure. It is in the position of the key that we want to remove. And so when we that's what this line of code here does. And after doing that, we are now going to free the current pointer and also equate it to null, so that it has no address within it. And what that basically does is get rid of that the structure in the key position, and therefore we have a new list that does not include that position. Now if we're deleting by value, here we still need 2 pointers, right? And we're going to first declare them, and we're going to create a node, because we have a value. We're going to use it to create a node, and that node is now going to be checked against other nodes, and if any node matches it, it will be removed basically. So we set a counter to initialize it to 0. So while remember, current is pointing to the head according to this, right? So while current is not null, we are going to increase the counter we're going to keep on incrementing by the counter by 1, right? And so then we shall carry out another test. So if because we remember we created a node that is labeled with a pointer test to it, as you can see up here. I can put the pointer there. Yeah, the pointer there. Okay, so if you can see that's a node we created with a pointer test. Now we're going to access that structure's number. We're going to access its number and then equate it to current's number. So every time we are traversing through the list, we're going to look at an element, access its number, compare it to the number of the test node, and if it's equal, then we go under this. If it's not equal, then we just keep on iterating, keep on incrementing the counter by 1. So now we come under here where if it's equal, if it was equal while the counter was 1, then in that case that means that's the first round, right? If for the first, let's say the first element is equal to the first element current the current number, and then is equal to the test number, then in that case the counter is equal to 1. So there, what we just do, we just get the head pointer and get the link in that element and assign it to the head pointer, so that now when since the head pointer accesses the first element, it's not going to access this element. It's instead going to access the element after it, and so the second element in that case becomes now our first element, and that means the first element has been deleted, right? But we also need to take into consideration what if it's not equal to 1. That's where the else part comes in. So that's why we have 2 pointers now. Excuse me. That's why we have 2 pointers now. So the pointer, the pointer, the current is moving forward. This other pointer is moving behind it, and this is we have named it PTR, which is basically pointer to the next. Okay, so we're going to get let's assume that this loop has ended up at a position where, okay, we are under the if the test is equal to the current number. Okay, so under that we are, which means the current is at a certain point, and the pointer is also at a certain point. So what we do there, we get the pointer since it's lagging behind, right? And we access the position of its link, and now we change that the address there to the address in the link part of where the current pointer is now pointing, the element where it's now pointing. In other words, since the current pointer is pointing to the the element, to the structure to be deleted, we are going to get the address in that structure to be deleted and assign it now to the element where the pointer is now where it's now where the pointer PTR is now pointing. which is the element just before the one that is going to be deleted. And that, what that does also, it sends us to the element ahead of what is to be deleted, and therefore getting rid of the element we want to remove. So it's just moving the addresses. And if we look at the free current, just removes what's in the pointer current, and also it initializes it to null, which means it now doesn't hold any address. And yeah, as you can see that okay, so that has been, the current point has been set to null. But remember, all this was under the if statement. So if we first go back to the loop, every time that we let's say our the test number was not equal to the current number, this is the rest of the code that would have been executed. The pointer is set to current, and then current moves forward, right, by accessing the address in the link, the next link, which that's what I meant by current lags behind the pointer PTR lags behind the current pointer. Current pointer is moving forward. So if you insert after key, we're going to apply some of the same techniques. We're still going to take in the pointer to a pointer, which is in that place, star head. We're going to take in a key, and then we're going to take in a value, because we want to insert a value at a key. So first, obviously, we're going to create a node that we want to insert. But we want to insert it after a specific key. So we're going to have to create a pointer, which is for this case is the current pointer, and give it the address of the head, basically. So if the head is obviously empty, then we are going to, if the head pointer is empty and there is no address in it, then we're going to assign to it the test test pointer, which is basically the pointer to the new node that we have created. In other words, we're just adding this new node to the linked list. Why? Because it has been empty, there has been nothing, so we're just going to add, because we're just going to add the element to the list. So now we're going to consider, what if now the key is 0? If we're adding it to the first position, so if we're saying that the key is 0 and we want to add the element after 0, in other words, we want to make it the second element, right? So what are we going to do for this case? We're going to change the link that accesses the second element in the first element to the link of the new node that we have created. In other words, the address, right? So that's what I meant. That's what this code here does. So we're accessing the link. First of all, the link that accesses the next element in the new node that we have created. In the new node, if we're inside the new node, the link that accesses the address that accesses the next element, we're going to turn that to what was the address accessing the next element in the first element at first, because this is now going to turn, because now the new node will be now accessing what was previously the second element, and therefore making it the third element, if I'm making sense. So if we are changing what was it that in that address, because at first the address is null because you've just created it's a new node, you've created the node. So if you get that address and you give it you make it now the address of the address that accesses what was formerly the second element, so that now it becomes the third element. Then what you're going to do is now get the address of the node, the pointer to the node, and then put it in the first element's portion that accesses the next element. In other words, the link, which is the next element. And so that's what this code here is basically trying to do. So test accesses the next link, and then assigns it a value of current. Remember, we created our current was equal to the head pointer, and so if we are having if we had the head, we're going to get the link in that first element to the next element, and then we are going to get that link and assign it to the link which will be accessing the next element for the new node that we have created. And then after that, we are going to get now what was now the space that was carrying that link previously, and we're going to assign to it test, which is the address of the node that we have added. That's if it's in the first element. So now, what if it's not in the first? It's not. If you're not, if our key is not the first element, then we are going to just basically iterate through until we reach the element that we want to insert after. So that's what this code here does. The current is just going to keep on moving, accessing the links until it finally reaches the one that it needs. That's why I'm saying, so for key not 0, it's going to just start from that key and keeps decrementing the keys until it reaches. When the key reaches 0, then it's false, right? So we break out of the loop. But at that point, the current is pointing. The current pointer is now pointing at that structure. But we want to add the element after, the new node after. So what we are going to do is basically the same thing. We are going to still access the link, the test link, and then assign it what was the address in our key position, so that it can access now the next element. Then we're going to now get that position that held that previous link, and then assign it the test, the pointer test, which is a pointer to the structure, next structure basically. Now if we're inserting by after value, we're going to now again have to look through the linked list, find that value, and if the value is equal to what the value to the new element, where the new structure we have created, then we are going to assign. Well, basically, if the data inside the number is equal, then we are going to at that point we shall now add the new node that we have created. So we're going to take in obviously a search value, the value which will be used to search for which element that we want to add to insert after, then the new value, which is going to just create the node, and obviously a pointer to the head. So now we're going to see that here we're creating first 2 nodes, as you can see on the screen. Then after that we create a pointer, which is current, and its address is basically the pointer to the head. But so if the pointer to the head is null first, we're going to that's if the list is empty. We're going to just make the new node, we're going to put the address of the new node basically into the head pointer, which means the pointer will just be pointing to the new node directly, because there was nothing inside the linked list, and now we're just going to put. Now what if the linked list already has something? Then in that case we're going to look for when current is not null basically. So if current is not null, we shall be checking if the number if we access the number at the number of the element that the current pointer is pointing to, is it equal to the number of the old node? Because the old node, we created a node using the search value, right? And so then its number, the number in that old node should match the number in the current in the current node being pointed to by the current pointer. So we access its number, we compare the numbers. If they're equal, then we go into this if statement. So if in that case, we're just now going to switch addresses as usual. So we're going to get the address that is the address that was in the position that accesses the next element, that link that accesses the next element in the old node, the value that matches the old node. We're going to get that address and now put it in the link that accesses the next element for the new node, right? As you can see, new node access the next bit of the next bit of the new node and assign it a value of current accessing next. So what was the link to the next element is now becoming to the next element previously is now being assigned, that address is now being assigned inside the new node. And for the address, now the address of the new node is now going to be assigned to where this former address was in the old node, or which is the node that matches the old node, which is where the current pointer is now pointing. And so we're going to access that position and then assign it a value of new node. And if we do that, we return. Now if this was not true, which means every time that it's not equal, the loop is just going to skip that whole bit of if, right? And it's just going to go and keep on iterating through moving the current pointer. And so that basically explains our code, our functions. So if we go to the main function, obviously we can start off by initializing our node, our head, to null. That's the first. It first initialize it to null, and after that, we shall have to allocate it memory, right? Which is done in one of the functions we created, which was create node. So every time we create a node, we now assign it memory. And that's what, so that we don't have, if we had not had that function, then we would have to allocate memory at that very point where we have equal to null. Anyway, we declare two variables, choice and data, then while one, which is also equal to while true. We are going to print those statements, and as you can see, then after that the switch command works as if an if statement. So for case when the choice is 1, we're going to print list. If your choice is 2, we're going to append. If your choice is 3, we're going to prepend. If it's 4, we are going to delete. So if it's choice 4, case 4, we are going to delete. And there are two options: we can delete by key and delete by value. That's why we have a choice. We're taking in a choice, scanning for a choice. Then we check if choice 1 will delete by value, then 2 will delete by, choice 1 will delete by key, choice 2 will delete by value, as our code showed. So if you case 5, we exit the program, as you can see. So yeah, then if we choose anything outside what we were given, that's the default section, and that there it's an invalid choice, and we can try again. So we don't need to break statement for here, because default not automatically breaks itself. So let's try out our code to see if it works, test if our functions are really working. So we're going to first print our first list to see if it actually works. It's going to be an empty list, and as you can see here, we have, after our choice 1, there is an empty list that has just been put up there. Then we can now add to that list by appending. So 2, we're going to append 2. And if we are to print the list, if we are to print that list, you see that now it has a 2 in it. And if we are to prepend now 3, and then we prepend 3 to it, and we are to print that list out, as you can see now 3 is in front of 2 because we are prepended. And so now we are going to delete, right? So deleting is 4, right? And so they're asking us, should we delete by key or delete by value? We're going to try out to delete by key first. So deleting by key, we are going to choose 1. So which key should we're going to first try deleting 0, key 0, which is the first. So 3 should be able to move from the list, and we only remain with 2. And when we print that list, there it is, we have a 2 only left. And so now let's first prepend the 3 back now to 3, prepend 3. Let's print the list. So you see the list now has 3 2 again. So we're going to now delete the key in the first position. So we're still deleting by key. Now we're going to delete key 1, which is the second element. So this time we should have that list only having 3. And if we are to print that list, there it is, we have a list having only 3, as you can see. Now we're going to try to delete by value. So let's first append 2 to this list, so that we at least have 2 elements. And so there it is, we have a 3 and a 2. And now we are going to delete by value, right? So 4 by value is 2. So which value do we want to delete? We're going to first try deleting the first one, which is 3. And when we print that list, that is, our list now only has 2. So we're going to now first prepend the 3 again, so we can have a list containing 3 and 2. Again, there it is. So now we're going to remove 2. So delete is 4. Okay, so delete by key, by value, sorry. Then which value are we deleting now? 2. And when we're printing the list, there it is, we only have 3 left. So now we have tried out both types of deleting. So we're going to try out our fifth case, which is exit. If I press exit, the program should stop. And when I press, actually let's first try out what happens if I press something out of the range. So we just stop the program last. So let's say I write 6, and there it is, invalid choice, please try again, and we're given a chance to try again. And so this time we can now close the program by pressing 5, and when we press 5, the program is finished. And yeah, that is a program that that shows the working the working of a linked list. And yeah, thank you for listening. I hope that all is understood, and have a great day. Thank you.